based upon yesterday's journey. So the thing is, yeah, we have to have that mindset. That is very, very important part. As a student, computational biology is part of our life. Always, yes, use computational techniques, whatever event you are involved, or whatever research you are in. So that is the basic part, very, very important thing. And a lot of online courses are there. That is why you have to learn by yourself. You are attending this kind of courses. Yes, that is one way. Another way, yeah, it's very difficult to go here and there. So that is why you have to register several online courses. So that way you can improve your knowledge. That is very, very important part. That's why as a student, PG students are also there. That's why you have to think out of the box. You have to come out. You have to learn by yourself. That is very, very important thing. Here no one will come and feed you, yeah, you do this, you do that. But problem with our student is, we have to do it like that. Yes. The purpose of this seminar is, yes, you have to realize your responsibility and accountability. And you should decide what you want to do. That's why, as per new education policy, yes, lot of freedom is they have given to the students. So you should decide by yourself. So if I would like to take any decision, so I have to have a lot of exposure. That is very, very important thing. That's why I am always saying, think out of the box. Because you are all, yes, one course structure is there, you stick to only that part. That is one way. But that will not give any, yes, utility for your job employment. That is very, very important part. So that's why your mind tuning, mind setting is very, very important part before starting your career. Otherwise, you may miss the bus. Again, I tell you, you are a research scholar or PhD scholar, whoever it may be. You are not planning properly, you may miss the bus. And waste of time. Waste of time. That's why. So, you have to utilize your think tank. Again, I am telling you. With respect to our status, we are saying that our think tank drive. So, put some water. Yeah, put something. And do it accordingly. Otherwise, very, very difficult, I am telling you. Because in this competitive world, yes, if you want to compete with mainland person, you should know many things. But during your career, you are not realizing. That is why as a teacher I am emphasizing that point. You don't have any goal. Yeah, if I am asking, yes, what is your goal, what is your objective? You don't know anything. You say, simply I say, I don't know, sir. That's why I don't want to expect that thing from your end. And as a teacher, we are having a lot of responsibilities are there. Yes, please remember that thing. If you are growing, then only our growth is there. It's a dual thing. It's not only from one end. So that is why you have to actively participate during your whatever program you are doing, and yes, you have to contribute to the university or your department. That is very, very important thing before learning anything. So that kind of approach, day by day it is going down. The awareness is not there. Because of your selfish nature. You are not bothering about others. Please bother about others. If you know something, yes, you propagate that thing to others. So that is a very, very important part. If you are intelligent, then only your words may be an intelligent person. Because I have seen that Runaway 34 movie. Yeah, go and see Runaway 34. No? Yes. Please help me. That is correct.
Runway 34.
Runway. Runway 34. 32. Runway 34 or 34. That movie is there. Yeah, please see that. Their famous actor Amitabh Bachchan is delivering one dialogue. Incompetent persons will breed only incompetent person. That is the moral story of that. That's why if you are incompetent, then what you can expect? What you will pass this thing to next generation? Yes, that is why again I am telling you are having lot of responsibilities and accountabilities. So realize that and act accordingly. That is very, very important thing. The still, no one is realizing. That's why we are conducting this kind of awareness program. But that way, because without hard work, yes, you can't do it anything and you are all thinking that you are all so relaxed. You see others. That's why, if you want to occupy high position, yes, you have to shed blood. This is the thumb rule. Yes. So that is why please realize this thing and register in your mind and tune your mind and act accordingly, because knowing is different, practicing is different. I know everything, but if you are not practicing, no use. Even you know, no use. Yeah, your group is very good. That is very, very important thing. See, man management, you see, you may be a dull-headed person, but your group is very intelligent. Yes, you can run the show. So that is a very, very important part as man management. Because we don't know many things. Yeah, that is why we are interacting with several persons. Then we are getting their help. So that approach, when it is there, yes, then only. And nowadays you see, as a student, yes, lot of pressure is there. You are expertise in only one subject, no use. Because now you see, that's why I am always telling this computational part is a part and parcel of our life. Without which you can't do it anything. Whatever job you are doing. Everywhere you see, morning to evening, we are using that IT technology, information technology only. But really, yes, that's why yesterday Dr. Rintu clearly mentioned, lot of free softwares are there. That's why, first of all, you should know that and you have to utilize those things. There is another thing, knowing is different, practicing is different. So that's why please utilize those tools. That is very, very important thing. You may think that, okay, what is the use of Linux programming and R? That's why, because see, if you want to present your data presentation is very, very important part. Are you good at data presentation? That's why what you are doing, that is enough. That's why. That is very, very, yes. That is why you have to have exposed to other person what is going on in real world. Because you are all closing your eyes. You are thinking that always dark. No. Open your eyes. Lot of light is there. Yes, light is there. No darkness. Because always we are thinking that, oh, we don't know anything. No one knows anything. That's why yesterday you have attended the 3 experts. Yes, the first slide itself they are showing. There is no background about anything. These are all our interests. If you are having interest, you can do it. That's why I am telling you. Again, take myself as a model. I don't know ABCD of anything. But without knowing, yes, I am doing. If I am doing, why not you? Yes, same logic. If I am doing, why not you? Only your interest. So that is very important part. That's why. So if you know, because normally we are using that Microsoft Word. Yeah. Once you are involved in Linux, then you know that beauty of Linux system. Yes. Now I hand over the session to our expert.
So today we have our session there only. We have both hands-on.
Oh, no, here our PG students are there.
Okay.
That's why if you are enlightening something about R or Linux, then that way it's very useful for because the motivation is very much essential.
I think they can come there and they can see
They
that.
have no space, sir. That is a.
Do you have installed in this Linux? No. So can I know the background of the UG students?
No, these are PG students.
Okay, PG students.
Yeah, all
No background.
No bad.
So I can just show you a couple of what you call it here. Programming languages which are very realistic. Okay. I think it's good, right? So yesterday, so this platform, okay, for the UG guys, we done for the for the participant yesterday. But I will just give you a quick overview of how we use. So for example, these are the different software that is available. For example, if you are looking for essay related softwares, if you have any biological equation related software or infrastructure, research field, and there are some applications are also there which is we call as a IDE app where you can just use as a IDE. Then you have various, majorly R is popular for its statistical programming. So you have statistical methods specifically for genomics. Then you have some technologies and workflow steps also are there which we will cover. Then you have annotation data. So annotation data is something which Imani yesterday showed you guys. Then how she uses this ORG HS annotation tools for doing mapping of the gene IDs. Then you have something to do with experimental data, how you store. So for example, these are the different what we call as packages data available. For example, this one is a single cell RNA sec. If you click here, you will get the whole details regarding what's the purpose of the what we call as the package itself. So it does gene level counts for collection of public RNA sec data set provided by single cell experimental objects. So these are the little bit of high level what we call as data types that is present in the viral vector package. So yesterday we covered little bit on how we can actually install R through Conda. So if you just go to the terminal, so this is typically the terminal how it looks like in a Ubuntu system. So you can install what we call as Ubuntu like system which is inside Windows also, which we call as Windows subsystem Linux. So you can just keep a note of the application. Then one more software which is we used yesterday, it's called as Conda, which is available as a mini Conda. So you can just type in Google mini Conda install. So after you install WSL, which is Windows Subsystem Linux, so you can install the Conda environment directly from this. So you will find that all the details of how to install the software is also mentioned. You can just use those. For example, I will just give you a little demo on how to create an environment where using the Conda itself. So you type Conda create -n is called as, for example, the name hello. Suppose R type. So it will ask whether I should proceed or not. So this is how you create a simple what we call as environment for doing your analysis. So you can just type on the activate hello dash R. So now if I type R in here, so it's saying that there is no R installed in the environment, which means that we need to install this. So for this, what we use Anaconda channels, which is you can just type. Since I already know this, so I can just type Conda install -C is the channel is R. Then we want to install R. So it will just install all the application for us one by one. So we don't have to worry about much of the dependencies also. So why we are doing this one? Because if you actually install directly the R in your Windows, so you will not sometimes you will not able to install all the packages which is required. So with this you can install a specific version of R and also a specific version of bioconductor whenever it's required, because during installation you will find that you have R, you have bioconductor and everything is there, but you are not able to install the package. So that time you can use specifically the which version of R you want to install and which version of bioconductor you want to install itself. And one of the benefit of doing Linux is that you can have multiple versions of your R inside one system, which is a bit sometimes difficult for Windows systems. Okay. So for example, if you look this one, this is our survival. This is a package used for survival data analysis. I'll just show you this once. So all the packages which is available in R, they are in the CRAN. So CRAN stands for Comprehensive R Archival Network. Okay. And inside that, for example, if you see anything related to, for example, here R lattice, which means that this particular lattice package is there in the CRAN. Okay. Just remember that. So for example, in this CRAN, you will get all the detail, like what the package does. There is information about the package which contains the core survival analysis routines, For example, the objects that is coupler here, then you have element nodes and curves, then you have Cox models, then you have parametric iteration, tailor time series. Most importantly, the advantage of using R is that you get to know about the package before you in fact using it. So there is nice documentation that you get, where for example you can just start with this one, which is the manual. It will give you an idea about what are the analysis that you can perform. Then you have a specific one if you have to go more deeper. The internet is slow. So one of the very popular packages that you will find for data visualization in R is called ggplot2. Just give you I think we got disconnected. Okay. I think that's the only approach that we will try. So let's take one second on the can read this. So we have our hello.r formula activate hello version. So I installed, so again we do that formula install minus C values are enough. Yes. So you see there are many packages that are getting installed. This is one are recommended. There is spatial. This is a neural network package which is for doing machine learning. Then spatial package is for doing spatial data analysis. If you are working with maps and all. Then this is the R base. R base is the minimal R without the packages. You can do your R programming using only R base itself. But since we are using you requested the minimal R, so there also you require with other functionalities also. So now if I just type R, so now you have the 3.6.1 which is there. But right now we don't have the diameter here. So for that we need to install one more package which is called as install dot package bio C, this means bioconductor management. So after we install BioC manager, now we can communicate with the bioconductor. Okay. So for example, we want to install a very popular a bioconductor package which we call as CSec2 BioC manager. We'll just load the library first. Library BioC manager. Okay, so it is saying that we need to install the available version of 4.2. So then we can effectively use the 3.6. So what we'll do, first we'll upgrade our R. Or how we will do that? We'll just quit. And let's install our R 4.2. It says it's not available here. So we have to look for another channel. So we will just type Honda install R4.2. Yeah, so we can have this another channel which is called as Honda forward. Okay, and we can just say channel Honda watch. Then you can say R base equal to 4.2. Yeah. So what we will do, we will just remove the previously installed R and it will install our the latest version of R 4.2. For example, if you now suppose you are working in multiple projects and you require R 3.6 but not R 4.2, what you can do, you can just create one more new Honda environment for R 3.6 and work over the project which is related to that one. Then if you want the R 4.2, you can just activate the specific Honda environment. So you can see here now R base is 4.2.0. Okay. So previously it was 3.6, now it is 4.1. I think they have actually also changed this version also specifically. Let me just quickly check. So see, this is 7.3.15. It was previously it was 7.3.11. So yesterday we covered little bit on the what we call as the version conflicts. So this is one of the examples where for a specific version of R you will require the specific version of special what we call as package. So those we are also called as the version conflicts, where you will not able to install the initial version of the latest one because your R is not upgraded. So usually for every day morning we will have a easy class.
No, this is only because yesterday and today is my class.
Oh,
So
no problem.
I have some kind of exposure.
Definitely.
I combined.
So I think in that case it maybe for you guys it will become a device, and I think they can learn about today what is Honda, and I think you once you go back you can just report submit a report, small report on what we call a package manager and environmental manager, which we call it the Honda as a one of the tools for doing that. Then you can write a little bit about R, and most importantly I think biochemical. Why biochemical is very, very important to learn. Okay, so now we are done. So we have now our version is 4.2.0, and let's again try to install our package. What was the package name?
Biology manager.
Biology manager. So the name is very case sensitive. So if you just type biology manager, it will not install. Okay, so you have to be very specific. So now we use library. Biology manager. So it's ready. So we can do install. I hope this is the correct name. So it is asking that for installing we need to operate this. We will say no for the time being. Perhaps you mean yeah. So the name is also this is the sector, not the sector. So now what is trying to install is all the dependencies that is required for that particular package. Okay, so you don't have to install individual packages separately, but you can manage this whole stuff. So this is like package manager inside R. Okay. So there are two things that you have learned. One thing for Linux, if you want to do package management and the environment management, that is Honda. And inside programming language also you will have program specific, like programming language specific package managers. For example, for Python, there is something called as P. Okay, and for R you will have something to do with installer packages, where it will automatically install your requirements for a specific package. So anybody done, I think there is no one who actually done the program, correct? And you have interacted with R previously?
Yes, sir. I have mentioned.
No, no, not you guys. You guys. So we'll do something really interesting. So in R, any programming language, first thing that you are asked to do is call it write a hello world programming language. Okay, that's the first thing that we will do. We will write in both the settings. In Python also we write and also in R. And we will just discuss about what typically a programming, why we do a programming in different. Okay. So the main purpose of having a programming language is to do repetitive tasks. If you ask me in a very basic way, that for example Python, if you actually do hello world, so we make the instructions to the computer that you print the information of hello world in the text in the data so it will show you back. So we just demonstrate that one here. Okay. So we'll just try with our Honda activate again. Now since we have R installed, so we'll just write something to do it. Hello world. Okay, now we have the information in this formula. Okay, so we just type on script and hello world. So you see the instruction whatever we have written in the text or in which we type. So if you tell the R that just execute this particular program, the program is in the hello world.r. So what was written is like inside that we have written print hello world. So the basic what we call programming task that you get whenever you actually any programming. We do the same thing for Python also. Okay. Just let's check whether we have Python installed. So we don't have Python installed, so we'll say Honda install -c Honda watch Python 3.8. So if you just remember this one, so one thing is that -c means channel. So then you will forget this. And we ask for Python specifically that you install the version of 3.8 version. Okay, equal to. So it is installing for us the Python 3.8.16 version specifically. So sometimes if you are very much interested with the specific version of it, then also you can put like Python 3.8.2 also you can put. So now we have our Python, which is already there. So similarly with R, you also get this kind of interface where it is mentioned which version of Python is there, which compiler it is using, which is GCC. Then from the Anaconda, since we have done this, that's why they have the Anaconda int also with this, and we are running in the Linux environment. So it is showing the Linux. Okay. So if you type Control L in the Linux system, so your screen will go upward. Okay, it will just screen your screen. So you can do the same thing with print. Hello world. So it will again print the hello world program for us. So this is inside Python we are doing. Okay, now again we will write log p by 5 and then we will execute. Hello log p by. Okay, so it is the same thing. Like we can, for example, for R you have to do a R script. Okay. For Python you have to type Python. So first is the program where we want to run. So for R, just remember it is R script, but for Python it is Python. Okay. And also you can specify which Python you want to run because you have availability of Python. For example, if I type Python 3.8, that time also it will work, hopefully. Yeah, because we are using the Python 3.8 at the back. Okay, now let's okay, it's installing. So meanwhile we can do something is I think so we can install the R for the Windows just to show the demonstration. For Windows for the first time. So R is very easy to run than the Python. So I will always recommend the life science scholars to start with R because it's very easy to interact with programming language. And also it is useful for your data analysis. So whatever if you go over relations, so you can make your own figures or you can do perform statistics on your data set also.
So now you are downloading R separately, not in Windows Studio.
No, this is just for demonstration because the Windows subsystem Linux does not allow you to have an IDE, the GUI, graphical user interface, because we are running inside the Windows. So I'm just installing outside so you can see the visually how the figures come. But for doing high-end genomics experiments, it is not, we will not able to use effectively in Windows. So when I started with my R journey, so I also started with the GUI only. I did not start it directly with Linux, but nowadays if you don't start with Linux, it's always a bonus. Where's the program?
You download Windows?
Okay, so who do you install? Yeah. So, okay,
GUI.
yeah. So this is how it looks like once you install R in Windows. Just let me stay patient here. So this is we call as a console. Okay, and this is the interface. So if you again type control Z, so the screen will get clear. Okay, and for example, whatever we have written previously, you can just print. Then we can see the message. So any string or the character which we are supplying, so we have to always put it in quotes. Okay, for example, I am a boy. Sentence. Okay, if I don't write this, that will show that there is some error is there. Okay, so every language has its format. So anything we want to put in this string, that we have to put in quotes. So for example, you can do math also 1 plus 6. Okay, you can do addition, then multiplication, divide, subtraction, and everything you can do. And this is type print. Hello. Okay, so one of the things that we will, I will just try to cover for you guys is that basic R. Okay, how we do programming in R. So there are a couple of things are called data structure. What is data structure? Typically, how do you store your information? For example, if I have a say a variable 1 which is var1 equal to say yeah. Okay, so this var1 which we actually let us increase the font. Size 16. Okay, I will use this visible. So if you just now, so var1 equal to hello. So this var1 here we call it as a string variable or a character variable. What do you call it? Character variable. Okay, and you see one thing after I put the hash, it is not actually counting that particular part. So hash is called as the comment. Okay, I can just comment something like I am defining suppose a numerical value. Okay, then I can just type my var2. Sorry, var2. You cannot put space in between. Is equal to suppose 10. Suppose 10 into okay, it will just type me hello. Okay, now I can just change as how I want. Suppose I say Vina dot to say Vina. Or if I say Vina Roy. Yes. So what we have done, there are two things that we have done. One is with the character variable and one is with the numerical variable. So you give an input and you take output as you desire. Okay. So for example, if you have a name where you put your surname at the last and then your first name, so you can actually reverse the order also. Then also we can do the reverse. Okay. So now we will just quickly move into something to do with there are one of the very famous what you do as plot, which is ggplot2. But before that, we will use a very primitive one, which is like the R itself which it provides. Like for example, the bar graph itself. Let's have something called a data which contains suppose bar 1 equal to C. So C is called as the concatenation function in R, where I say A is having 12, then we have B equal to, and suppose we have 50, then we have C equal to suppose 4. So now bar 1 will store the values. For A, corresponding value is 12, for B is 50, and for C is 4. Now you can use simple functions like bar plot, inner, and bar1. Okay, you are able to create bar graphs. Okay. Okay, very very simple. So if you have some experimental data and you want to visualize, so it's very easy to visualize also. So now let's suppose I want to change the color cell of the A, B, and C. Three colors I want to put. That's also very very simple. So at this time, bar this comma. So colors is equal to, let's suppose I put red, then red blue, and suppose green. I think it's called scores, not colors. Okay?
So what is the command set? Color?
So color is called, so color is not a command but it is a parameter. So the function name is called bar plot. Then you have a call as a color where you can change. For example, I can say sky blue here. So it will change to sky blue. Okay. Suppose we want to make it horizontal, not like vertical. So you can just type as comma horizontal equal to true. I should know it was. So now your figure is horizontal. Okay. So suppose you want to now annotate your x-axis and y-axis. Okay, let's do that. So we will say it's something to do with x lab equal to, let's suppose this is, letters. Okay. Then you have y1 is the figures. Okay, it's got reverse. You can just type x lab. So now you have what you call as labels of the examples. Okay, and suppose now you want to actually put this figure for your copy or for your report. So this is in the now the R interface. So how we can do that? So there is something called as PNG. Before that we will just check where we are. It's called as get working directory. Get WD. So we are right now in users Lenovo documents. Okay. So first we will try to create a folder for us where we can dump our analysis. So what I will do, dir dot create. Okay, let's suppose I will create hello R folder. Now if I will then create one more which is called as hello.r figures. So we have created two directory from R. So you can just go back to your folder and if you go to documents, you will find there is a hello R folder is there, and inside that we have created figures. Okay, from the R itself. So now you can dump your figure inside this figure folder. How we will do that? First we will say png. Then this is the folder name is hello R, then figures. Then we have to name our file. Let's suppose I will say that bar plot. Okay. .png. Okay. Then enter. Then we will just type our bar plot. Then we say dev.off. Okay. So what we have done here, so the png is a device function where if you open the drawing, for example, if you draw something with your hand, if you have to do painting, you require the canvas, right? So likewise, the png actually creates you the canvas where you want to draw your figure. So we have opened the canvas with png. Then with the bar plot, we just put on the canvas. Then the dev.off actually closes the canvas for us. So we just quickly check. So we have our bar plot here. So we can open Oh, it's already opening from there.
It will open with paints.
Paint, we can use paint quickly. Okay, let me open in the browser, it will be quick. Yeah. Okay, but this figure is not publication quality. You can see that your what you call it, labels are very small, bars are very big. So how you may edit this? So we will now do that using. So you can control this by saying width. Okay, width you can say give 600, or since width is more, you can give it as 700. Then you want to reduce the height. For example, height, let's suppose it's 500. Then most importantly the resolution. Okay, if you ask like the publication always asks you for resolution. So you can just type RIC equal to, suppose I give 150 resolution for a time being. Then I can just again run my MLC. So just refresh this. See? Now it's more clear. You have the letters ABC, then the frequency also right exactly as you want. Sometimes what happens, for example, this becomes a panel inside the figure, it's just a panel. So how do you do that? So you have to put across all the panels. There are softwares are there in R where you can do panels also. We call them as a, like for example, grid. Extra, that's an additional package which you can load. But I will just show you a demonstration of how we can do two panels using R. This goes bar, MS row, then we see of, suppose that we have two rows and one column. Then we can have one this figure. Then we can change something a bit here. Screen. So just change the color here. So red. So this is a figure which is two panels. So here panel 1 and panel 2 it is inside one figure itself. Okay. So we can just put outside this whole information. We create a figure 2. For us, bar dot 2. Then since we have now increased, we have two figures, so we will just increase our height also.
We can make it as a TIFF file.
Yes, we can do that also. I will show you in the next step. Depth dot. Yeah. Okay, I forgot to just scan a couple of stuff. Okay, so now you have two figures in the same. So for example, to just get those perfect, you can increase your height. So just change the height parameter. So this one will give you, for example, 900. Increase more. Okay, why I change the width that time? Okay, so this is how you can do play with your the parameters, and you can get specifically how you work. So if you have to reduce the width, you can just change the width parameter and you will get the whatever your desired outcomes. Okay, as sir mentioned, we can actually do with TIFF also. So like PNG, we will have TIFF. So where you can generate a TIFF file. Then you can have PDF also. For that you can have PDF. So these are the available devices. Okay. So if you want to know about more, you can just do a question mark and do a PNG. So it will show you the what are the available graphical devices are there. BMG, JPEG, PNG, then you have TIFF, and there are different formats are there, for example. Okay. This is a bitmap, then JPEG, then you have PNG, then you have TIFF, and all the other available what we call it. If you are doing a PNG, then your unit is in pixel. If you are doing TIFF, the unit is also in pixel. So we have used the resolution one, which is this one. Okay. Then you can change the other family like font family also. So and you can change the background also. For example, here we have the background of white. You can change it to gray or any other ones. Okay.
So what is the command to check this one?
Which one?
To check this command.
Okay. So you can just go there. For example.
Just I have to write the PNG.
So for example, this one we use the PNG. This is a function that we use. Okay. Now, as it is mentioned, so you can change the background also. Like for example, BGY. So you can just keep a background here, as suppose gray. BG equal to gray. Then anything we will plot, it will come into gray. Then drop off. See? So the background is not changing. Okay, so it is like for the canvas, what color we want, we want to have not so white, not gray one. You can change color specifically. Okay, the same thing we will do with, one of the most important package that you will always come across is called as ggplot2. ggplot2. So this package is having very lot of advantages. For example, you can make very beautiful figures like this. Okay, and you have all the materials online available where you can try. For example, yesterday we showed about dot plot, correct? So first one thing we will do is that we will just install this package. So as we have done previously, we will just then install dot package. ggplot2. Say yes. Yes. Okay. So in the Indian class they have to do file linking analysis, right? So for file linking analysis also you have lot of modules are there for reclustering based on your the features or features can be of your sequence data set or you just collect sensitivity, those can be also done here. Okay, now we will just do a library ggplot2. So what we have is our var1, right? var1 is a ABC. So ggplot always cannot directly take this as a data. So ggplot2 always require a data frame. So we will now, so this was a vector. Okay, var1 is a numerical vector. We will convert this one into a data frame. Okay, data frame is nothing but a tabular format data set. So data dot frame of suppose var1. So this is more of like now tabular format where you have the ABC in the rows. Then you have the information like the frequencies are as a var1 which was we already mentioned. So we will just create one data dot frame. Then we will say var1. We call this as a var1's data frame. Okay, equal to this. So var1 and data frame. So one of the most important thing is now there are two information here in the table format. One is the row name which is ABC. Then we have the column name which is var1. Now we want to change to our requirement which is like we want to keep one more column we want to get which actually tells about the ABC. So how to do that? For example, I can say var1 and df and I can keep something like called as dollar. Dollar means that you want to add something or you have to access. So right now we have only one column which is var1. So if you type that then it will automatically fill. So var1 information. So var1 will have 12, 50 and 4. Okay. Now for corresponding this we require the names, for example that is ABC. So we can just keep the name for name equal to C. So since ABC is character, so we put quotes B then C. Okay. So now if I just type var1 and df. So now we have added one more. Okay, this we never had previously the name column, so we have introduced one. Now we will change our name of var1 also. How we change that? We can use something known as column name is equal of var1 df. So column names actually gives you the column names of a data frame, and likewise you can do the row names also. Okay, which will give us the row names. Okay, so for example the row name is ABC. Okay, now let's suppose we want to change the name from the var1 to something like the frequency of ABC. So how we can do that? First we will access that one. So we will access the var1 only by putting square bracket. Okay, the square bracket is very important here where you do subsetting or in fact then extract the information. So if I try to, what will come? Yes, name. Yes. So the name will appear. So now I can change my one equal to suppose frequency. Okay. Now if I just do var1 underscore df, so we have changed appropriately now. Correct? So the numeric values and then column and call frequency, then we have the name. So and also we will just remove our row names from ABC to 1 to 3. Row names is 1 is to 3. So if we now check, so we have very appropriate data for our ggplot. Okay. Now we make the same bar plot using ggplot. Same type of bar plot, but we will get more aesthetic and will be more appealing. So ggplot data is what or df var1 underscore df. Then we call as aesthetic is aex where we want to go. It's x equal to what? In the x-axis we want to keep the names. Okay, for the point. So you have the name in the x-axis. Then in the y-axis we want to keep it the frequency. So it's abstract. Plus gg. Okay, this is geo, the geometry of bar plot. So in bar plot, you can actually the ggplot we can make barcode for you directly if you have a vector. But since this is our statistic, so we'll say the statistics you don't have to compute for us, but it is whatever it is there, just plot it. Okay. Then we say stat equal to identity. Okay. So now you have the barcode which is ABC, and with the name, with the frequency, we do not have to read anything. In the previous one we did X and where you have the name of manufacturers, OD, the model which is specific car, then other parameters, and also the years where it was built. So in the figure what we have the different classes, okay, SUV and others. Then you have the displacement, then you have the HWI for the both of the all the cars, different cars. That is it. So I will recommend you can go back and just play a little bit of R. Then a biometric I cannot show because it needs to install. If it's already installed, then I can just show you quickly. I would say no. Okay, I think we need to install a lot of other packages also, like XML is required. So we'll do this most probably, you can consult your PhD student whenever you are wanting to do a genomics. Okay? Is it fine? Okay. I hope you have understood.
Thank you for
Yeah.
Thank you. So now we take the lead, and after the we will go.
Yes, I agree. Tapi yang ini
Oh, that's why so fast. More faster.
Now we're not going to you. Yeah. How much? How much? Yeah, about this? Okay, I will one of my friends is saying I will call Yes, planting.
Yeah, so there's something personal. Correct their personal user ID. There is the cd space dot dot. Cd space dot dot. Cd space dot dot. Very good. Now make mkdir Yan MZU dash OSSC. Okay.
Sir,
MKDIR.
the screen is low.
Wait, no problem, no problem. No problem. Sorry. Okay. MKDIR Gyan dash MZU dash OSSC. Press enter. Okay. Then type CD Gyan. Then you can press tab. It will autofill your rest of the characters. CD Gyan MZU OSSC. Yes, yes, yes. Enter. Okay. So now go to GitHub.
Sir, after the city gear and get to OSC, products, then?
Done. Now go to GitHub. Go to GitHub. GitHub.com. Your user ID will come out. Okay, this is my user ID. So you will have your own.
Yeah, your profile.
Everyone is here? Okay. Now in the right hand side corner, just press. So you will get this. Your profile, your repository, right hand side corner. Right hand side corner. Go to settings. From there, go to settings. Sign in. For which you have to sign in with your So if those who are not signed in, please sign in. We can wait. So the page will come, for example, if I don't have a sign in, I will sign out. So it will ask for sign in. You can do sign in and your user ID and password. Just close the thing.
यूजर नेम जो था पूरा नाम था
Okay. Everyone is here? Just sign in. First sign in. Then go to settings.
Why on?
Okay.
After you go to settings, in the left hand side, you will find SSH keys. In the session, after session, you will find SSH keys. Go to settings first. Settings. Then in the left hand side of the settings, you will find SSH GPG keys.
Yes.
Okay, click that one.
Yes.
So for example, I have created one SSH which is called as Gyan Mizoram OSSC. Okay, I will delete this one for the time being. Okay, so now you see there is an option for new SSH key, right? So before that, we have to generate the SSH key. Okay, how we'll do that? So just click in this one, generating SSH key. Okay, you will end up here connecting to GitHub with SSH.
Yes.
Okay, come down. Then you will have something generating new SSH key and adding it to the SSH agent. Just click there, generating a new SSH key. It's already there in the screen. You can see in the project.
SSH agent.
Yeah. Just click there. So you will get this page where you have Mac, Windows, Linux. So we are using Linux. So we will come down, and there is a nice instruction that is given that how we can generate new SSH key. Okay. So there is a SSH key gen -t RSA and this, and there is one more is there SSH keygen -t ed. Okay, we will use the first one. Okay, SSH keygen -t ed. Okay. So how we use that? Just follow me. Just watch how I am doing. Now you have to come to terminal. Okay. In terminal you have to type SSH. Okay. Then -keygen space. Then you have -t. Then you have AED 25519. Then in quotes your email ID. My email ID is rintukutum.com. Oh, sorry, rintukutum@gmail.com. This is the email ID that you use for your GitHub account. Okay, just remember. Okay. So this is the full code. So use put inside your email ID inside this. rintukutum@gmail.com. Yes, so the email ID you have used to create the GitHub account. अभी इतना ही कर लो वो सब इतना ज़्यादा complicated. Okay, once this is done, please press enter. I will just do.
Dear participant, please note down all the steps simultaneously.
So now, sir, one G has been generated.
Yeah, welcome. So in after you do, so basically what you have to follow, you have done, na? Too many Hare Baba.
You also said it.
Someone's already done.
आपको बन गया क्या?
Repeat the exercise.
आप इसमें एंटर डालो, again enter, again enter, one more enter, okay, again enter, okay. So there is something that came, there is root dot sh id 2219 pub, okay. So I'll just get there, cat, then press root, then you have dot ssh, then you have the id, then dot pub. Okay, let's do cat. Okay, I'll clean the screen again. Cat, then slash, then root, then dot ssh, okay, then id, then pub. Then what we generated? ed25519 dot pub. even करो टाइप करो cat space
Slash
वहाँ पे देखो slash एंटर मारो.
Sir, it is saying permission denied.
Okay, permission denied. Okay, there is some mistake you have done. You have not put in one slash after sh. Careful. Put the sh. You have to write exactly.
After cat there is space, sir.
Yes, yes.
Sorry.
After cat there is a space.
Yes. Yeah, the one. Let him try. Permission denied.
Yes, sir.
Yes.
Enter the same thing.
Permission denied. Oh my God. So too many.
Cat slash space.
सबका permission denied आ रहा है.
No gap. After root slash no gap. Yeah, dot ssh slash id.
Under space.
But
Just try.
Everyone is getting.
Sorry. Cat. Space. Then forward slash.
Yes.
Then kk. Dash. Forward slash dot sh.
मेल आईडी नहीं ले रहा है.
Do tab.
मेल आईडी नहीं लिया है.
नहीं चाहिए.
नहीं या वो कोड था तो बोलो तो.
slash id.
मेल आईडी दो.
You take something. Do it from here.
I think your
So I put all the views. Put on the
but might not.
वो दिया अगर नहीं ले रहा है.
I think there is a root permission issue is there.
Permission denied.
Yes. So you need to have a root access. Now how to do a root access? हमारा root access है ना? नहीं, root access तो easy होगा. इसके लिए root access नहीं
Like the eye of the cycle.
Control
हो गया ना?
He generated
Heat generated, it is there inside your home. What you call DRDA was that copy that one where it is written saved in the top public generated in the top. Come down.
probably he has
Copy this one there.
I gave
Home.
you
Just type cat, then go to home. Okay, for those who it is not working with the keychain one, so I will show you another way to do it. Okay? Yeah, that's right. Yes. Yeah. Minus 6. So just type again minus C in front of your what you call as email address. Go up, press up. In front of your email ID, just press minus capital C. Space. Minus capital C. Yes, enter. Okay, then after that press again. So press yes. Enter again. Keep pressing enter unless you get this screen. Yeah, keep pressing it. Yes, very good. Now, so you, for example, for my one which is already there. Okay, select SSH. Fine. Very good. SSH. Very good. Everything is there in SSH. Now copy. Then there is a double square bracket. Square is there. Just click there. Double square. That will have double square. Okay. Now it will show copy. Okay.
yes sir.
Click there. Copy it. Very good. Now go to your terminal. Back to your terminal. Go to your terminal and type git clone then paste. Sorry. Git clone
space, then will paste sir.
yeah then the paste. I will just copy
Git space clone.
clone yes
Git space clone.
git space clone space and paste. No okay control shift वापस जाके कॉपी करो. Right. So for those which is control V is not working, you can click right click. That's it. Okay. For those who has been done, it's good. Okay. Why you are doing this again? Yes. Just type yes. Enter. What do you do? Yes. Fingerprint is yes. Press yes, then it will automatically download. Yes, press yes. Type yes. Then press enter. Perfect. Very good. Very good. Yes, yes. Press yes. Enter. Alright. No. Okay. So now what you have done? Okay, what happened to you? Did you press yes? No. Okay, you have to press yes. It's done? Very good. Very good. So what you have done right now, yesterday we discussed this, correct? So the GitHub, Git and our system. So our system right now is local. So our system is what? Local. And the GitHub is the remote. Okay. So anything, whatever modification we will do in our readme.md file which is there inside. So before that you go inside the folder. The folder name is demo gyan mz.
Yes.
Just go to cd space, then type demo. Then use tab. It will autofill. Yes, very good. Then tab. Very good. cd demo tab. Press the tab. Tab. Very good. Then press enter. Okay. So now do ls. Now do ls. After pressing enter, now do ls. क्या कर रहे हो? Concentrate. No mobile now. Okay. Okay. So you will find inside readme.md. Is it there?
Yes.
And the license file is also there?
Yes.
Very good. So you have to do ls. So now yesterday we did what? We did vi. We will do again vi. Vi. Again press readme.md. Just use a tab to autofill. Just press R then tab. Very good. Then I think you remember what we need to do after pressing enter. You have to press I. Correct? Very good. And press I, then come down. So please write this. Double hash. Then day 1. Okay. Just check whatever I am writing. Please replicate that one. Then day 2. Yeah. So you have to press I. Okay, you are use Vim, not Vim. Only VI.
Double hash. Yes, let me discuss. Double hash.
एंटर मैंने सब नीचे पूरा
Right hash, double hash. Come down first. You have to use the arrow. Okay, then enter.
Sir, 01, 02 both you can move, right?
So I will just magnify. Wait. So this is what you have to write. Hash day 01. Come down and write hash 01. Okay, then hash day 02. Okay, it's there. Very good. Yes, put space. Okay. Yes, you will require space, and then whatever you want to write, you write. You want to write a poem, you write. Whatever you want to write. Today is a day 2. I will write a poem now. Okay. We are all enjoying programming. And lunch is ready. What to do here? I am not hungry, but you guys are.
I am hungry.
That's what I am writing. Okay, so this is the poem I have written. You can write your own. Okay, just type. Press enter, then you write something. Write whatever you want to write. More you write, na? What is this? Oh, inside the then DI inside this you have to write.
Git करो.
Then is it done? Very good. My poem is done. I don't know about you, but I am now going to save. What is the mechanism? Escape.
Escape, then colon.
Press escape. Yes, yes. Hit colon.
Shift colon.
Then right is W.
W key.
Then Q. Then exclamation. Okay. I hope you guys have remembered this. Anyway, you will be using this multiple times this week. Then enter. After you, okay, again do escape. Then go to shift colon. Colon. Not so many. Very good. Then write W. Then Q. Then exclamation. Then enter. Perfect. Very good. So now if you do cat, just do a cat readme.md.
I don't want to type anything.
And enter. So whatever you did modification, it is there. But if you go to your browser, GitHub, that changes is not there. Just check once in the GitHub, online, remote. Just check. Whatever you have done, it is not there in the GitHub repository. Okay, in the repository, if you do refresh, you will not find the change. Go to the circle, refresh. Press refresh.
Yes.
So there is no changes happen yet.
Yes.
So what we will do, we will now send our whatever we have done, the poem whatever we have written to the internet. Okay, how we will do this? First, git add. Okay, git add, then the file name. What is the file name we have modified? That is the read. So add double T. It's fine. It's just escape.
I did.
Okay, you did not open any file. There's no file you have opened, so click just type then the file name. Okay, only here. Now let's suppose you will write a poem. It's small poem. Okay. No. This is what he is writing. So it's there, but it's not there in the top. So what we will do? Then we want to add this, whatever. Okay. Now type. After you have done this, just enter. Git add readme.md. We have done enter. Then we will say git commit. Now we are going to get married. Okay. We have to git commit. Then what message you will write? -m. I will write anything, whatever you want to write. Okay, I love you, I will write. Okay. Okay. -m means message. Okay. The message that you want to put, you can put anything. I have written I love you. You can write I hate you also. No issue. Okay. Whatever you want to write. Or you can type hello, whatever. That is a message. Okay. Is it done? No problem. So for
Please tell me who are you.
yes, enter, press enter. Very good. So now for you there is some message will come extra which is saying git config. Okay, git config.
Yes.
Type git type git config. It's there in the screen only. Dash global. Okay, space user dot name. Okay, inside the code type your email ID. Okay, user dot space.
For me, I have this after that global then dash edit. So I will type this one.
Yeah, for you it's edit dash edit. Yeah. That's it, enter. Okay. Username mine is Rintu, so you will have your own. Just type your email ID. The same email ID you use for your GitHub. Okay.
Something.
Git config user ID email ID. Is it done? Very good, very good. Just press enter.
Sir, what's the link? I have to put, sir.
Sorry? Yes, yes. Then you have to type after you are done with the user email. This one, sorry, it is email. Email it is. Then you will have a name which is my name is Rintu. Okay, I'll just clean the screen again for you guys. So git config global. User email is my email address. Then my username is Rintu Kutum. But for you it will be differing. Okay, don't type Rintu Kutum. Your user email. Very good. Enter. Enter. Okay, ಕೊಡ್ಲಾ ನಾವು ನೇಮ್ ಕೊಡು. यूजर ईमेल फिर उसके बाद यूजर नेम आपका जो यूजर नेम है बोला ओके इज इट डन हो गया then try to push now. Okay, very good. After this is done, I will do git push. Git push. Yes. Username you are already done. Okay. Now do git push. Enter. Okay, now go to your website. You will see that your change is now there. Just do refresh, go to your page, go to your demo. Very good. Okay, just do refresh. Is there? Very good, your poem came. For those who have written their poem, they came. It's not there yet, yours. So you have to push. Okay, your okay, is it there now? Just do a refresh. Okay, your did not came.
Sir.
Concern. Oh, okay. Something is wrong. So you again do the commit. Add again. Add. Go up. Add. Enter. Then go to your commit. Yes. Enter. Now push. Git push. Now. Perfect. Now go. Yeah, very good. This your point here? No, this not. Yes. Okay, you are? कुछ तो गलती किया तुमने बहुत गलती कर रहे हो so for that for those who it is not saved it is there then again you will commit then you will give go there go back Dinata go back there and okay it's already done
They have to run
yes go run very good you will
Commit, sir.
Okay, now it will go. Everything is done? Or your the problem is there? Sorry, boss.
Now go there, refresh and check.
Just refresh. There? Did you write any point? It's there. Very good. So we will come back again and we will repeat. Everything is up to date now. So now you have to do again add. Okay. Then you have to do again combine. Okay. So this is what there the changes there we made. Read your point. Now your point came? Very good. Your point came? Check. Perfect. Beautiful. So now your point came? No. Then you have to add your point first. Go up, press up. Up arrow, go up, again up. Up. Yeah, 8. Okay, this is your me, right? Now again 8 press up and go to commit. Okay, you now it is done. Now check. Perfect. Okay, so what you have learned? Who's having problem?
Suppose you are working in collaboration with someone. He says, give me a code or okay, so I am sending a YouTube property. If you want to add, delete, insert something,
Okay, so like in R we can save it. Here we can't save it like that. In R we will be saving our code, right?
in R you save the file. Here, not R is the extension to save. In GitHub, the file is saved. Like in R you save on the file, document, this. But in GitHub, it's on the cloud. So it saves on its own. Like you put in and this, that. So it saves. So if your PI wants to put your code, you will open that .r file and then you will see the code you want to add, delete. If you make it public, if you make it private, then only you longitude and latitude of the world of my location.
Now you verify He's hardly there with us.
But time place
Right now, we are whatever we will do. चलो दिन का बिजनेस
बता रहे हैं ना, तो कैसे वो मैप दिखा देगा उसके लिए स्टार गेजेस पैकेज होता है।
नहीं करने से हो जाएगा
नहीं
स्टार गेजेस पैकेज होता है वो लोकेशन बता देगा कब पुलिस मुझे जिस पैकेज के लिए यूज करते हैं इसका एडवांस चीज होती है थोड़ी। जैसे टैक्सोनॉमिकल एनालिसिस करने के लिए स्पेसिफिक अल्फा डाइवर्सिटी करनी है तो पहले हम कौन कौन सी स्पीशीज चाहिए आप अपना मैप जैसे कोविड फैला था जैसे आपको कर्नाटका में बेंगलुरु का जगह है और मंगला में कितने इन्फेक्टेड हैं कितने प्रोन टू इन्फेक्शन है और कितने इन्फेक्टेड नहीं है कितने सेफ है वो आप मैप के थ्रू बता सकते हो। जैसे वो नहीं है कोविड-19 वो आर के पैकेज यूज
No,
उसका नहीं देखते कैसे वो नहीं करता तो बड़ी जैसे अपने पब्लिकेशन में टेबल ऐड किया था ऐसे टेबल बना इसको फिर एक्सपोर्ट करके देखते हैं।
Like did add was a command. Then you
Hello students, Are you comfortable?
Yes, sir.
Is it? Okay, now if you are so much comfortable, okay, now you will write something. First, create a Conda environment. I want to see how many of you will come. Just create a Conda environment. Call as R4.42. R42. How to create? Yes. Conda. Create space. Create minus n. The name R42. R42. Yes. Minus n space. Minus n for name, not m. Conda create minus n, then R42. Space is required, then R42. R42. We are going to install R4.2. Okay?
R space 4.2, sir.
R42. The name, not 4.2. R42. R42, yes. Then you press yes. Then after that enter yes. Then you have to activate. Conda activate R4.2. Then I think what we need to do, if you want to install R4.2, you have to go to repository. Where? Anaconda repository. It is done? Now it is done. Now you have to go to Conda Forge. You remember Conda Forge? Conda install minus C Conda dash Forge R equal to
Conda Forge.
install. First you have to install Conda. Then Dinita will do it. For those who are not having Conda, Dinita will install. Command not found. That software is not installed. Then R equal to 4.2. Enter. Very good. Very good.
Install.
You have to install that one. Dinita will install. Conda Forge minus space
Conda install, Conda dash Forge.
Conda install dash C means channel. Conda dash Forge, the channel name. Then space, then R equal to first activate power. 4.2. Yeah. Very good. Very good. Forge equal to space what? Sorry sir. Space R smaller. R equal to 4.2. So then yes.
Conda Forge only. Hyphen.
Where hyphen what?
Conda command not found.
Sorry? Command not found. Dinita will help you out in installing that. Very good. Yours is done? So now you have done you have done not so much confidently. Again you will do this.
Sir, yes.
First deactivate. Again you deactivate. And repeat this exercise by building your own environment again. This time you will type my R. Okay? Not R42. Conda create minus n my R. Create your own name. 4.2. Yes. Okay, now you create your own now. So before creating you have to deactivate. Conda deactivate. You wait. You have to repeat this again and again so that you know you will never forget. Practice, 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 practice.
Website बनाने के
My answer.
रजिस्टर क्या करना है?
Will you create it first? Conda 3, I6,
ये फाइल है ना इंस्टॉलेशन कैसे कॉपी करना
किसका किसका कोंडा नहीं है?
कोंडा जिसका नहीं है डुप्लीकेट करो और उसके बाद इंस्टॉल करो। डुप्लीकेट करो और इंस्टॉल करो। वेरी गुड, वेरी गुड। ये एक्टिविटी वेरी गुड। परफेक्ट। Bring here.
रिस्टार्ट कर लेना शायद यहाँ पे ये मारो
Parenthesis.
साइड देख दो so who is not having conda
Very good.
so he is having
That side only, that corner, that corner.
नहीं फास्ट वो
you have conda Arka
he has that. He doesn't have.
you want
Install.
creating
Practice, practice. Those who have done are now inside your environment. Install Python also. Python 3.8. Install Python 3.8.
I think it is already there.
Check. Python. Not there. Install. Yes.
सर मेरा वाला नोट आया है क्या उधर?
नहीं है।
Equal to people.
Yes.
Why?
Sir, done, sir.
Python install is also done. Okay, those who have done the R installation, next to the Python installation. Quick, come out. Install Python.
हो गया तो थैंक यू कोई इंसुलिन मिल गया हो गया लेकिन तो नोट ही गया है
वही तो वो अपने आप भेजा हुआ नहीं हमारा
हो गया ना हो गया इट्स अनपेड
Then you no, that to be in that so we did another now you are making new now Python it's not this Python is without Python. Okay?
Sir,
Python.
sir,
Yes. You have to deactivate, then you have to again reinstall. So now what we have is inside new R42. That is the environment. We have to stop R is also there. Control R. What do you want? You want the blue Honda or you want the
हम लोग Honda create करते तो नहीं होता बोलो ना सर
नहीं खुद से
So you have yellow Honda also created R4. Okay. For example, now you have to install R inside this or this. Where you will install. So now R4 you have to install. Now install the software. Honda install. Install. Base. Channel name. Space. Honda 4. Dashboard. Dashboard. Equal to space. Okay, next you can try Python you have done. Na? Very good. Now you can practice code, you can practice. Yes. You can try start doing the exercise. Yeah, you can just do it now. And just practice on one more task. Install R, then by taking. First you have to deactivate. You have to come. Yeah, try Conda deactivate, right? Very good. So now you see now you need one more time. Now if you want then install R minus A and any anything. Yes. You can You're done, na? Very good. Practice one more. The more you practice, the better you remember.
R equal to 4.2.
No, it is not there. So I think you have to do again W again. No, where is the play? On the side? On the side?
On that side, it's saying
Now wait.
After you install and activate, you will be counting yourself.
6 minutes.
Then we want to install this and whatever you want.
You install and you are installing here after automatically go and yesterday
So they ask for you to put what you call it, run the Conda in it.
So then restart.
You must try again and again and without saying your
Same problem, sir.
So that semi-dry transfer instrument. You guys have semi-dry transfer instrument for Western blot. Facing we have the reagents in it.
Yeah, we have everything. So,
I have PCR master mixer.
yeah, we have. So, like, atlas we have.
Isolation.
Yeah.
So you have to start everything.
Okay.
We'll do the RNA isolation first.
Okay.
Then CDA preparation.
I will bring volume when you will tell me about relation.
No. In my system, there was some.
Okay.
then you have to be there.
So what you can do?
ಮಾತ್ರೆ
அந்த மாத்திரை தூக்கம் வரும்
ನಾನು
அப்படியா சரி ஓகே நான் பேராசிட்டமால் இருந்துச்சு
That's why I was trying to.
தூவணுமா
Texas comes up. It is not a
Sir, Bindu sir.
Yes.
taxi is here.
Okay, wait.
Okay, wait.
And whenever you are pasting that sequence, one sequence and another sequence, you give one gap. Okay? Give one gap. You select 5 sequences.
Who's system making sound?
Okay, you have collected 5 sequences
That
now.
one.
So you open another window.
Which one?
You type cluster omega. Cluster omega. Cluster omega. You see that screen? Yes. So cluster omega is a multiple sequence arrangement. So there you can go there. Yeah, because you have taken protein there. Correct? So now all 5 sequences you can paste it there. See, either you can paste it or choose file and automatically it will go.
But all 5
Yeah, choose file, yeah. This way, yeah, because if you are having 1000 sequences, very difficult to do that thing. See, whenever you are comparing 1000 sequences, that time you please use only accession number. Don't use sequences because it is occupies a lot of space. Correct? So come down and yes, you can submit. Yes. See now this cluster omega doing that alignment. Yeah. You see now you can color that one. Show colors. Cluster omega. Don't go for cluster W. Cluster omega. Take it that way. Okay, so now you see here, very important part is, see different colors are there, correct? Different colors are there. So that color, what it shows, that is showing your physico-chemical properties of the amino acids. That way they are grouping. Amino acids are different, but their physico-chemical properties are same. So that is why you are seeing different color. So now what you do, you go to bioinformatic tools FAQ.
You collect the signals of that all and paste them.
All sequence, all 5 sequences plus this is multiple sequence. All 5 sequences you have to paste it.
After pasting, sir? No, you can also paste it at once.
Yes, all the thing you sub yes.
I have pasted here.
Yes, then submit. Submit. Correct. Okay, you come down. In that bioinformatic part, yeah, you come down. Yes. Again, come down. Substitution. Correct. Yes, see, different colors are there. That's why you go to bioinformatic tools FAQ. There you see, see the color they are telling, correct? What do the colors represent in protein alignments? Correct. In that, that's why. So now you check both the things. Correct. You see your alignment color. So red color is yes. A, B, F, P, M, I, L, W. These amino acids. See, these are all small hydrophobic amino acids. Yes. Blue color is acidic amino acids. Magenta color is basic amino acids. Green color is either hydroxyl group or sulfhydryl group or amine group. Like that. And the grey color is unusual amino acids or immuno amino acids. So that is the meaning of that color pattern. And below that also you are seeing the different colors. So you can check with your alignment. Okay. You can check with your alignment also. So first of all you have to know about that. So overall coming under red color. See, for example, in another window, you open, take amino acid single letter. Go to another window, amino acid single letter. Go to images, yes. Yes, take, yeah. So now you see what is A, what is V, yeah, yes. So you should know about that thing. A is alanine, V is valine. So these amino acids are different, but we are grouping as same, correct? So now you check with your bioinformatic tool, no? FAQ, red color, green color. So whatever amino acids are there, so this is very, very important part. You should know about that point. Okay? So that way we are grouping. So though amino acids are different, but their physicochemical properties are biological properties are same. That means their functions are same. Even amino acids are changing, nothing will happen to your function. That is the meaning of that color. Then you go to your multiple alignment part. Yes, come back to result. Result summary. Yeah, you go to result summary. See there, one is dot is there. Result summary. Alignment. Yes, you go to alignment. Make it color. Show colors. Alignment colors. Here you see very important part is colon is there, star is there, and dot is there. So what is the meaning of that? That's why without knowing this concept, you can't do compare or do anything. So that is why. So if it is a star, what you are seeing? See, in star, what kind of amino acids are there?
Similar.
Wherever star is there, all amino acids are same. All amino acids are same or different?
Same.
All are same. So exact amino acids. So wherever star is there, yes, exact amino acids. Now what the sequence alignment, what you are doing here? You are seeing here. See, you have taken different leptin proteins, correct? Different leptin proteins you have taken, and now you are comparing. So wherever that star is there, that is exact amino acids, correct? So here another important part is, yes, your conserved amino acids and semi-conserved amino acids. Two things are there. So your colon is conserved. Dot is semi-conserved. Okay, so now again you go to bioinformatic tools. Yes. Control F, you type conserved, semi-conserved.
But sir, here different analysis are also there, no?
Yes. See, the single letter code, you see what is here, what is here. See, it means amino acids are different, but their physicochemical properties are same. That is why, yes, we are telling conserved. That's why you go to here bioinformatic tool, control F, to type conserved or semi-conserved. You will get that thing. How they are falling under that conserved residue. Asterisk mark, yes, fully conserved residues. So now, what kind of amino acids are there? See, the question is, what do consensus symbols represent in a multiple sequence alignment? Correct. You go to bioinformatic tool FAQ. Yes, there you type control F, type conserve. So then you will get that one. So please remember that one. Colon means
Sir,
fully.
asterisk is showing conserved.
Yes, yes.
Asterisk
Asterisk mark is fully conserved.
fully conserved. Colon, yeah.
So that fully conserved. Yes. But colon and dot.
Yeah.
That means they are telling period. Colon and period. Dot is period. So colon. So what it is shown? Yes. Amino acids are there, but their properties are very strong. On what basis they have grouped? Based upon PAM matrix. Have you seen? PAM matrix 250. Yeah. What is PAM? Yesterday I told. What is the PAM?
Point acceptance.
Yes. Your PAM matrix is increased means those are all similar. Yes. So similar in terms of what? Physicochemical property. Please understand that point. Conserved, then colon is, yes. Correct. Then your period is, yes. That also there, but weakly similar properties. That is strongly similar properties, colon, but period is weakly similar properties. So that is why they have given that PAM 250 matrix they are giving. Less than 0.5 to greater than 0. So these are all the points you have to note down, and you have to understand what is the basic principle by which we are inferring your phylogenetic relationships. So finally you have to give the relationship. So how will you write? These are all the important points without which you cannot write anything. You cannot see anything. Okay? Now you understood what is fully conserved, conserved and semi-conserved. Okay? Fully conserved is asterisk mark. Conserved is that colon. Semi-conserved is dot, that period. So semi-conserved means weak similar properties, weakly similar properties. But colon is strong similar properties. So you are clear about this point?
Yes.
Okay, so here alignment, but in that alignment you see, now you come to alignment, you see, what is the leptin gene? What is the role of leptin? Anyone knows? Okay, you go to another window, type leptin gene. Because whenever you are working in bioinformatic thing, you should know all the things, then only you can work. So what is the role of that leptin gene?
It is making leptin hormone.
Yes. So your leptin level is going high in blood. That means what? That shows what?
But the gene is more expressive.
No. I don't want that one. Your leptin level is going high means obesity. See, obesity major problem nowadays among younger generations. So you are obese means first test what you have to do, you have to check your leptin level. Leptin level increase means yes. Previously we thought BMI that way we have calculated. But nowadays, see, leptin gene is there. Yes, it is producing the hormone leptin. That is a protein. Yes. So that way clearly we know that okay, you are obese or not. So that is the role. Okay, now you check. You have taken leptin gene from what are all the
5 sequences. So here this sequence of this sequence I want to compare.
Please understand.
Oh no, I want to see this is highly conserved. Okay, fully conserved. So can we compare this with this also?
Only two?
No, not two. 1, 2 with this three. I want to compare all. Because we are doing multiple sequences.
So whatever you are seeing in the document, see that is a portion. Please check that number. Your number you please check. In your case, if you are seeing there, see this is 41, 39, 58, 39. This particular portion is matching. Like that. 101, 99, 118, 99. So always you are comparing with that 5 thing only. You understand? Everywhere, yes. So that is why next you go for
This is for whole 4 we are comparing.
yes, 4. At what? Because your amino acid sequence from 1 to what is your size of your amino acids?
180.
186, 183 like that, correct? The positions are there, 1 to 186. So in that position, which one? Yes, it is aligned. Where similar regions are there, correct? That means fully conserved regions are there. Conserved regions are there. Semi-conserved regions are there. That thing it shows. That's why it shows different colors. And that star, colon and dot. So that way we know that point. So now what you have to do, whenever you are doing that working on molecular phylogeny, you have to take print screen, then you have to show this thing. You understand? That is very important point here.
Yeah, here this sequence will also be and this will also be.
I hope you are clear about this point, correct?
Because the function is a protein.
Because see, nucleotide mutations are there. Most of them are synonymous mutations, neutral mutations. So that will not affect your protein. So here our main point is, yes, protein, that is a very important point. Is there any change in that? Even amino acids are changing, but yes, based upon the physicochemical property, nothing will happen. Yes. Are you clear about that? So that is why.
Here I have taken this sequence. I have number this, I have number this. So here it is showing 41 nucleotide. This is 41, no? Yeah, here 41. 41, here 39. It means that.
This is number.
These are nothing.
41 is there. Here 39 is there.
Yeah,
Here
which
58
in
is
between
there.
that is gap. It means that among these 4 sequences, they have these are the conserved.
Yes, correct. Fully conserved. That is conserved colon. Not this semi-conserved.
Yeah, semi-conserved.
Please understand that 3 term and this coloring pattern. Yes. So this way we are doing that multiple sequence. Correct. Correct. Now yes, how we are, see, then you can go to and go for gated phylogenetic tree. Click that phylogenetic tree. Okay, now you tell me here, yeah, after seeing the tree, yeah, what story you want to tell? See, you are taking only two, that is wrong. See, that's what I am doing. See, that's why basic common sense should be there. Use your common sense. Okay, you are taking only two, then means that is pairwise alignment. Correct. If it is should be more than two, then only it is multiple sequence alignment. Okay. Yes, always you have to remember that. Okay, now you are seeing that your tree. So what it shows? What it shows? That's right. What story? Because this is picture, correct? You are visualizing a tree. So what? What that thing shows?
Ancestors, from where it is.
No, my point is, you see, any tree, one starting point should be there.
Rooted.
Correct? And one end point should be there. So where is your end point in your tree?
These.
Yes. Now you tell me individually, where is your end point? Where is your starting point?
Starting.
Yeah, this is your D. Okay. Where is your starting point?
Upper key. Here.
Starting.
Explain.
And where is the end point? Say, no, my point is yes or no, that's all I want. Yes, show me here. Where is your, where is your starting point, what is the end point?
Below.
Where is start, where is end, that's all I want.
Based on the evolution,
This is start. Where is end? What do I want to say? This is start or end? This is end. Or this is start. That's all I want. This is start. This is end. Okay. What about yes? Where is start? Where is end? That's all I want. See the picture and tell the story. Yeah? That is start. That is start. This is end. Okay. Okay. This side, what you are telling? Start and end. See, in metagenomics you have studied about OTU, operational taxonomic unit. Yes, operational taxonomic unit is nothing but your species. So that is why here you have taken a lot of sequences. Yeah, which species you have taken that leptin protein. So in your end, there your operational taxonomic units are there. That is the end.
This one.
Yes.
This is OT.
That is your operational taxonomic units. Please remember that point. See, now we are coming to the tree. Correct. Whenever you see tree, origin should be there. That's why I am asking, where is the starting point? Starting point you have to have. That's why we are telling rooted tree, unrooted tree. Unrooted tree, see what you are seeing, that is unrooted tree. That is why you are puzzling. Where is start, where is end? That may be this way or that way. So that is why, again I am telling you, phylogenetic relationship. What is homology? We are finding similarity based upon common origin. Yes. So that is why origin point is very, very important part.
Sir, after increasing sequence now it's rooted tree. Rooted tree and rooted tree.
Rooted is anything. Anything, that is not yes, you will see in Megaya. Better way we can see. Okay. So that is why whenever you see, whenever you are doing See, you are seeing that that tree, correct? So your starting point is origin. So that is why you have to make one starting point. That is origin. Origin is there, then rooted tree. There is no origin means unrooted tree. Okay, you check with figures. So rooted, unrooted, right? Then after that you see, you are seeing. See, we are using the word cluster. See, cluster means as a group. But here, see, here how will you see the cluster? You see, your origin point is there, correct? After that you see, after that one more you see, that's why, what is your that fourth species? Everywhere you see 2, 2, 1, like that it is there. 2, 1, 2, like that it is there, correct? In your case, yeah, 1, 1, 2 is there. Yeah. What about your thing? Yeah, 2, 1, 2 is there, correct? It's 2, 1, 2. 2, 1, 2. 1, 2, 1. There, your case.
Father equal to 1, 1 again.
And what is the meaning of phylogenetic? What is the meaning of phylogenetic?
Relationship.
Relationship.
Clear cut definition. What is phylogeny?
Evolutionary relationship.
Huh?
Evolutionary relationship.
Evolutionary relationship. Then that's all. What is evolutionary relationship? Phylogeny. Philo, time, genetics. So one is what is your genetic difference? Then that thing we are compared with time, over a period of time. That's why we are telling phylogeny. But here we are talking about molecular phylogeny. We are considering molecule. Always remember that one. Here, what is your molecule here? Leptin. Yes. Please be clear about that point. Because I took 2 hours class, and then after that I asked my student, "Hey, what is your gene of interest?" 2 hours I took one this leptin gene. Okay, I explained all PCR, ECR. Finally, I asked that question: "What is your gene of interest?" Sir, what is gene of interest, sir? Here, where is gene, sir? So that is why, please remember that one. Yes, you have taken protein here. Correct? Leptin protein you have taken. You are taking nucleotide means that is leptin gene. So always remember that one. See here, cluster. That's why wherever, see now initially one origin is there. You make one line, then you will get one, yes. Then after that you see, after that origin is one. After that you see, it is divided into several clusters. Correct? So here if you are seeing there 2 clusters are there in this thing. So wherever from that origin, these are all called sisters.
From this.
Closely related. Yeah, from this here, this is the origin. Using originated point here, but some type of differences are there. See, what your tree shows
Means these and these are distantly related.
Correct. Because now, see, now this is different species.
Yeah.
But if you are taking same species, yeah, you are getting like that means these are all variants. Understand? Now you are seeing different species. From where you have taken that leptin protein. But if it is same species, suppose whenever you are coming to microorganism, we are telling strains. Correct? Microorganisms, we are telling strains. Then whenever you are coming to animal, we are telling biotypes. Whenever you are coming to plants, we are telling ecotypes. Yes, so there any variations are there? Yes, it shows everything here. So same species, but origin also different, but yes, their protein function is different. That is why. So that's why that concept is very, very important part. Because whatever you are showing this tree, that is developed based upon your branch length. Branch length means what? Distance. These are all distance based methods. Okay, phylogenetic tree. So now you see, you go to another window, you type distance based phylogenetic trees. Distance based phylogenetic trees. So distance based phylogenetic trees, what examples are coming? Distance based. Or you type distance and character based. Distance and character based phylogenetic trees. You type it, yeah, what types of things are coming? Have you find out any tree? Otherwise, type it phylogenetic trees.
This one, sir.
Phylogenetic trees. You go for this one. Otherwise, you can go for Wikipedia. You will get what kind of trees are there. Or phylogenetic tree building. Anything you can type it. Phylogenetic tree building.
Yeah, this one.
So what are all the trees are there? That's all I want.
This.
Tell me. No, name the tree. That's all I want.
Neighbor joining.
Neighbor joining tree. Okay. Then
UPGM.
UPGM. Okay.
Maximum likelihood, maximum parsimony.
Okay. Maximum parsimony. Then
VCR.
maximum likelihood. Have you seen?
But
Maximum likelihood. No, you can open one thing, that thing, you can open it.
Sir, after these.
Okay. You see, the trees.
Yeah, this
Two
one.
types are there. One is distance based, another is cluster based. Okay? That's why you have to check, yes, distance based, character based. Okay. This is images. You can go to images. I'll tell you.
This
Yeah,
one.
click this.
This one.
Click this one.
So this one.
No, distance and character based trees.
This one, sir.
Yes. You take. Yeah, you check that one. Yes. Distance is this one. distance and character based trees. Yeah. And yeah, this is the very important part. That is what is in some common phylogenetic methods. You please type that one here. Some common phylogenetic methods classified according to the data. Yes, that one. Yes, correct. Yes. See, always remember that table here. That's all here. Because you should know about that thing only. Okay. Apart from that, you type it. I told you some commonly.
Some commonly.
What is the title of that one?
Some common phylogenetic method classified according to the
Some commonly
according to the data used.
Some common phylogenetic
Common phylogenetic methods classified.
some common one by one. You can all are talking.
Some common phylogenetic methods classified according
Yes.
to the data used and the method used to build.
Yes, this one. Check that one here. Yeah, that is that's all. Yes.
Classified according to the data.
Yes, that one. Yes,
Image में check करो.
this one. Yeah, this one. Yes. Yes, first one. Correct. Yes. Okay. So see that one. Yeah, that is self-explanatory. So two types of tree things are there. One is distance based, another is character based. Right. Then what kind of algorithm we are using? One is clustering algorithm, another is optimality criterion. Optimality criterion algorithm. So whenever you are coming to distance based, but we are following clustering algorithm means your UPGMA and neighbor joining. Two things are following under distance based, following clustering algorithm, UPGMA and neighbor joining. Okay. Next is, if you are coming to that optimality criterion, following optimality criterion algorithm. Yes, one is distance based means your minimum evolution. Minimum evolution, yes, based upon distance based but optimality criterion algorithm. But whenever you are coming to that maximum parsimony and your maximum likelihood, these are all character based. But see, these are all the updates. So initially we have followed distance method. But whenever you are working on biological organisms, we should follow character based method. Because distance based method, it is giving bias. That means bias means wrong conclusions are there. And another important part is, whenever you are coming to that, what kind of algorithm you are using? Clustering algorithm. Cluster means, yeah, whatever this thing is there, yeah, it will make a cluster part. But that is not a good method. So that is why we are using that optimality criterion algorithm. So there two methods are there, especially character based. Maximum parsimony and the maximum likelihood. So that is why, yes, whenever you are publishing any paper on that phylogenetic, molecular phylogeny, yes, reviewer, they will say, yeah, you can go for maximum parsimony. Yes, because maximum parsimony purely character based. But whenever you are coming to the maximum likelihood, it is totally, yes, statistical based. You are telling no, P is equal to less than 0.05 is significant. Yes, that thing, yes. See, we are using the term log odds ratio. Log odds odds ratio. You see that thing? Yes. Log odds ratio. Okay, so in all our phylogenetic method, see, we are going to use that mega tool. Okay, but before going into that, you should know about this basic thing. Log odds ratio. So what is the meaning of log odds ratio? See, here we are seeing that similarity. Correct. So how much similarity is there? 100%, 90%, 80% or 50%? Same, yes. That statistical part, we are, because these are all sequence thing. Correct. So here what we are doing, what is the maximum frequency of that particular amino acid, or what is the maximum frequency of that particular base pair? Yeah, based upon that we are calculating. And what is the particular frequency divided by our total frequency. So that way we are following that odds ratio. Please remember that point, because you have to understand what is what. So maximum likelihood, yes, everywhere we are following that odds ratio, log odds ratio. Why we are converting our data into log transformation? Anyone knows? Log transformation, arcsine transformation.
Minimization.
Huh?
Minimization.
Why you are doing?
Because huge data we can't handle, so we want to have a minimum.
Small value like 0, 1.
How?
So that
Easy for our
use,
interpretation.
yeah, for easy interpretation. But this big value.
Correct. You understood? No, yes. That is why we are converting the data into log transformation. See, whenever you are working on toxicology, normally we are following LD50, lethal dose 50. Lethal dose 50 is nothing but lethal concentration or dose at which 50% of the population died or 90% of the population died. Yes, but see, this thing we are observing. Suppose we are taking 10 animals, okay, 7 animals died. So we are telling 70% died. But in reality, it is not like that. That's why for that, in toxicology part, we are using arcsine, ARCSINE, arcsine transformation. We will convert that percentage into arcsine. Okay, arcsine transformation. But here, log transformation, why we are doing here? Yes. That way, yes, you can minimize that variations. And exactly you can point out, yes, how much variation is there. Because in our all phylogenetic studies or statistical studies, what is, why we are following statistics part? In a simple way, can you say? Why we are following statistics? Without statistics also we know. Why we are following statistical tool or bioinformatic tool?
To know the significance.
See, to minimize the variation. That is the logic behind all analysis. Because in statistics, we are taking only the sample. Population is as a whole. Suppose if I am working on mosquitoes or honeybees, I cannot collect all honeybees available in that particular site. Yes, not at all possible. So that is why because whatever it is present, that is population. So part of population is your sample. So here always in all statistical part, we are comparing sample data with population data. That means sample mean with population mean. Sample median with the population median. Sample mode with the population mode. So how much variations are there? So based upon that we are taking the decision. That is called hypothesis testing. Whether you have studied correctly or not, yeah, please, I brushing up that part. Hypothesis testing is that thing only we are doing. Yes. What is the, how much variation between sample and the population? Yes. That's why your p-value is coming. Probability. P-value, yeah, significant. Less than 0.05 we have fixed. And apart from that, you are telling that confidence interval. You have seen CI. What is that? Suppose your P value is 5%, then confidence is 95%. So 95% authenticity is there. That is authentic. That is the meaning. But when you will follow this odds ratio, because here we are not getting any value. All are sequences only. Either amino acid or nucleotide. So that is why we are finding only the frequency. And especially here we are not following mean. We are following either median or mode. So from there, what is the frequency of that part and divided by total number of frequency. So that way we are calculating that log odds ratio. So whatever we are converting that thing into log. Please understand that point. So now if you are coming to that, yes, character based. Maximum parsimony is a character based, but maximum likelihood is statistical based. Other way I can say model based. Please remember that point, because what is model? Model is nothing but we are in a layman term, yeah, because I don't know mathematics. So how I can understand what is a model? You are telling ecological modeling, molecular modeling, or drug modeling. What their main purpose? Purpose is, yes, based upon that past experience, past observation, we are following certain formula, correct, to solve our problem. Yes, that is called modeling. Yes, several models are there, probability models are there, correct. Already you have studied about binomial probability distribution, 50-50. That is all routine activities, 50-50. Then Poisson distribution, rare events, that tsunami, earthquake, flood. See, flood is there, all officials, they are going only by helicopter. We are all laughing, this fellow, I am suffering, this fellow going on. Why? That's why based upon your aerial survey, they are estimating all the thing. So for that, what model they are using? Poisson model distribution only they are following. Accordingly, they are allocating money to, yes, different state. That particular state is asking, so I want 10,000 crores, but they are giving only 5,000 crore only. Why? On what basis they are giving? Based upon that Poisson distribution model. So model is very, very important part. So that's why whenever you are going to your mega, so you may see, yes, first of all you have to test with model, which model is better. So now you go to window, Google, then you type DNA models. First of all you have to understand that point, DNA models. In Wikipedia, anything is coming. Check it. Molecular models. Come down. You type it DNA evolution. DNA evolution models. Wikipedia, you see DNA
Models of DNA evolution.
evolution
Substitution models. Nucleotide substitution.
Different models they are describing. What is this one here? What is the title?
Most common
That's right. What is the title?
title.
Models of DNA evolution. You type it models of DNA evolution, Wikipedia. See, you read any book, you will not get any clarity about what model. Whenever you are seeing that mega, Yes, we are not in a position to find out what model this thing. Yes, you please study this thing. See, most common models of DNA evolution. Yes, see, there are so many models are there. Jukes Cantor, K80, K81, F81, Felstein, T92 model. Yes, GTR model. So this is your latest thing. So now you are going to see this thing. Whenever you are using Mega, you will see. Oh, that is GTR model. Yes, Jukes Cantor model. So this model totally depending upon your transition and transversion. I am telling you now, transition 2 times more than transversion. On what basis? That is K80 model. Understand? Yes. Please read this point and clearly you please what model, what message we are getting. So now if you are seeing that Jukes Cantor, what they are telling? Yes. Whatever that mutation rates are equal. That means transition is equal to transversion. So that is Jukes Cantor model. Yes. So then come down. Yes. So like that. Yeah. K80 model. That is Kimura 2 parameter model. K2P model. That is what thing. Yes. That's why transition 2 times more than transversion. So that is K80 model. So that's why model. That's why you have to select proper model. Which model suits for you? And see, this model is there, but automatically that tool will suggest you. So what model is favoring your that kind of phylogenetic part. But we should know what model, what it is. Then only you can write many things. You can do a lot of analysis. Without knowing is very difficult. Okay. So now you are about this model part over. And distance based and character based basic thing. Correct? These are the things we should know.
Sir,
before.
Suppose we have taken this 5 sequences. This like 500 or 600 sequences. I want to see them.
That's why we are going to use. That's why meta. Okay. So now you go to your window. Type it mega 11.
Mega
11. MEGA.
Mega 11.
Yeah. MEGA. Mega 11. Yes. So Mega software is coming. Yeah. Download. Yeah. 64-bit. Your thing is all. Yeah. You have to check what is your system. Whether it is 64 or 32-bit. Accordingly, you have to.
This is Mega X and Mega something.
No, Mega 11 you have to do.
Mega 11.
Okay, उठ जाओ, नीचे जाओ। आप वहाँ पे जाइए।
हाँ, ये रहा ना Mega 11.
क्लिक कीजिए।
ये
वो नहीं है भाई।
ये नहीं है.
आप व्यापार खोल रहे हो।
नहीं वो नहीं खोल रहा ना.
So Mega is nothing but molecular evolutionary genetics analysis.
हो जाएगा।
Okay. Yes. So now we have to check. I am a researcher, student, professor. Yes. You can give your that minimum thing, and after that you can download in your system. Okay. Correct. Yes. See now your file is there, correct? You have already downloaded 5 sequences. Yes. That is notepad, text file.
हो जाएगा।
So you have to convert that text file into FAS file. First you download.
मेरा क्या पता
Correct. So all you have downloaded, huh? Yes. You are finished, then we can go for next step. No, otherwise you can download anything, Mega 5, Mega 6, 7, anything it will work. So your Mega 11 is the latest version. That's all. So a lot of options are there. Download.
Yes, sir. Download.
Oh, download. Okay. So now, yeah, overall downloaded, yeah, you have to convert your that text file into fast file here. Correct? Fast
So
file.
not faster.
Faster, yeah. See, now what you do, you go to your,
So if they are, I think they are with Getadem they have started recipes. Getadem. Their recipes in Getadem. They have already uploaded.
that's why. Yeah, first yes, they can upload. No, first they
Then
can
send it in
download.
mega format. Fasta file sequence download करो.
Faster file already it is there now.
First of all, you will get 5.
Faster file.
Yeah, you already have, right?
Already have. So now we have to convert that thing into MEG file, MEG. Because then only Mega will recognize that file. But before that, yeah, we have to do alignment. Understand?
Sir, it is downloading. Give us two.
So here, what you have done? File.
File open.
1 minute here.
Where is available?
They can 1 minute. They will do. Then you tell here.
Sir. It is downloading. 2 minutes.
Oh yeah, no. Overall downloaded. Yeah, you.
Yeah, first download and then install it.
Okay.
Once it's completed,
Ah.
then raise your hand.
File. First download. Install that part.
Now you install it. Open. Yes, okay.
And here what you are doing? File,
Open. File.
data.
Oh.
You are going to data.
No, sir, I
No,
can't.
first data.
File open. Already open, so that option is there.
Oh, file. Okay.
File. Open a file session.
Open a file section. Open a file.
Then we can.
After that, you are sending your
Selecting that
faster
faster file and open.
open. Then you have to make it as align.
सबका हो गया ना?
Yes. Now you have downloaded.
इसका देख लो ना.
Downloaded. Then you can install. You can install.
Who has installed? Kisne? Who has installed?
Yeah, those are not working. For the thing, yeah. This is for Mac, na? This is for Windows, not for Mac. Mega 11 for Windows, okay? Not for Mac. Because this is Windows.
The another important part is overall downloading. You have to go for Windows. Mac also there, Windows also there. So you have to select Windows.
Yes.
Mega for Windows, na?
Related dot form. You should upload it faster. You rename it as the extension should be
Just run, type that Mega
faster. If it's
11 Windows.
Now you
Yes.
Now you do align with this one.
Accept. Please align. Accept.
DNA sequences. No, export align.
They are now students of the university. So let's come.
You have done already, yeah? Mega format you have done, huh? You have done. Mega format already done. And go to data. Save file na.
Move to align. Then build a new alignment. Create a new alignment. DNA. What DNA here? Protein. Then here insert. Insert. And then where is your file? Protein file.
Say overall this thing you have already aligned, huh? Okay, go to alignment. Yes.
Select all, first you will select.
Which you have done alignment. The alignment you have to select.
What's that?
Then you will need to save.
Yes, no.
Yeah, you are telling now I am having 10,000 sequences. So you have to go for master. Okay, now you are seeing very important part is this one have aligned, what about data?
Yes.
Just you go ahead. What is the class selected sequence?
Yes. Yes. I accept.
Finish हो गया. Just stop. I have to give for you. क्या है जो लेबल मारे हो ना उसको फ्लेक्सिबल होता है ये कहाँ करना है व्यवस्था बहुत अच्छा है
Export please already not mega format. So another export data and export alignment it's already mega file. Not mega
Select all. Alignment. You need to select that.
Save.
Previously done this
Choose file.
Then after alignment.
You have exported into that mega format. You are all done. No, you have done that alignment done. No, then you want to go for file.
Alignment to fill in. That is data.
Say this one.
Mega file.
You have done that thing already. Then you want to give this. You want to convert that thing into mega format.
Okay.
Align, then build. New alignment, create new alignment.
You have converted into mega format.
Then this is all routine, right?
Yes, you have to convert that thing into
And
mega
then you put
format.
insert, here insert. And then what is the
And once you have done, then you have to go for models. This first thing you have to know about that thing, because that thing only you have to find. You have done, huh?
Next one.
Before that, where is data? Your data is compute for analysis. What you have done?
Yeah, I think you do it. You select all steps. Control later.
Export alignment. Then mega format.
Then data will start. Data, then export alignment. Export alignment, mega format. Keep in desktop, keep it in desktop. Okay then. So click desktop, click desktop. Click desktop. Now do it. Now we give mega, sequence 1 mega. First
Export data data. Another file is how to model. Find the best DNA for the model.
JPT plus G model. Best fit model.
सबसे बेस्ट मॉडल ये data now you see
पूरा मॉडल नहीं
so here it is using
Now I have given data done, right? That's why it's operating now. Previously you don't have data done sign that. That's why it was not operating. Then
it is there. See, missing is one thing all sides each
after that you have to
if you want once you
these are different files. The Nexus and file these
that is a default model banana. Now the opening models. So you have to prepare and you have to give which model it is to
now it's set. Now it's a model and then you can view this
you have seen the model.
now our file is based mega file, mega format. Now you are
Dear participant, see, we are facing with our students. They don't know ABCD of anything because they don't know the concept.
Yes. So why we are building model?
That's why first you go to model and find the best model. You go and click. Yes, get that result. Find a best model.
So first you save your data in mega format. After that go to model and then
Below that you read what is see here very BIC and AIC. What is that? See in that model.
and what basis you will select the base model now?
Yeah, BIC is there, AIC is there. What is that? Below it is
See
written.
down it is there. Base
Down
model.
it is there. You click and then see. Yes. Yes.
BIC,
See, BIC, AIC. What is BIC? Bayesian Information Criterion. AIC is Akaiki Information Criterion. Two things are there. So BIC and AIC. Based upon that, we are selecting that model. See, you will get more score there. You go top. So many models are there. See, so your model is JTT model. What is the JTT model? Yes, go to another window and then check.
So we have to select the first one, where the BIC value is lowest.
Yeah, you are also getting JTT or G model. It is there. So this information, AIC, this information you will give it in your table. So this model we are selected. Here, GTT plus Psi model.
So lowest value you have to pick. These model.
Lowest value you have to select. This thing whenever you are building so what model, best model or your so that point you will get. So all are clear about say that's why you please note down your what DNA model you are choosing. So you have to prepare table like this. Okay. So you have to select yes BIC and AIC very low value you have to select.
नहीं इसमें टेबल नहीं बनाना, इसमें आपने वो क्या है कि आपका कौन सा मॉडल सबसे बेस्ट है, ठीक है? इसमें से now you have to select.
So now, yeah, you please note this. This is the very important point. Then again, you are going to go to yeah.
This is not like
Minimize
now
that.
you can say
So next is you have to go for data.
BIC for this and this for this.
You have to go to data.
Okay? Just wait. Don't do anything. Let's explain then. Okay? Okay. Yeah. Let him explain then.
Go file takes.
Select all then align by muscle.
Select.
Control A, then go there.
So this is leptin gene, huh? Vertebrate.
By muscle. Okay.
Okay.
Then now go to data
You select.
and then export alignment to mega format.
Okay, you select first one. Vertebrate meta one, right?
Then now you give yeah, now save. And now you have to give it to one.
So that is
export alignment to mega format.
Now it is size
conserved size, variable size.
I have taken.
So this is the highlight. See the statistics. So you should know about highlight. Yeah, what is conserved side, variable side, single information side, single.
now go to model and find model Betty.
Yeah. That thing you please.
First one.
So here separately is there. Conserved side, variable side, singleton side. What is singleton? Find out. Because this way only you have to give analysis part.
Just हो गया
बिना
This is what files.
क्या मॉडल सेलेक्ट कर लिया ना सी सवाल सेलिंग ना दो टाइप के फाइल हैं वन इज डिस्टेंस बेस्ड वन इज कैरेक्टर बेस्ड ओके सो कैरेक्टर now we will go for character based so character based methods are mainly following the optimality criteria okay so optimality criteria are like these character we are selecting okay so for that we have certain model so now we have tested that model okay, for our sequence first that model was jj something is there that is best fitted so while we are going to build the tree so we have to select that model अभी बाहर बोलेगा ना why you did this Sonia what is this
Single term. Like that, you have to check and you have to note down and you have to prepare it. Then you have to analyze what how many variant is more, concern is more. So here very important what is that parsimony information site.
So now what they have built the part now they are waiting for user what they have to do
Model you have done and go to the TA. Yes, there you have to come here.
what is the first
Highlight, yeah, see, conserved site, variable site, parsimony information site and singleton site. Okay, you click that C. Yeah, you see here below you can see out of 186, 55 are conserved sites. These are all conserved sites. So what are kind of amino acids are there? So you have to note down and you have to prepare. And same thing, the variable sites. How many variations are there? Out of 186, 114 sites are
then what you have done
only 7 only. Very less. And same thing, your singleton site.
I want to see that.
So this thing,
I want
you have to note down and you want to prepare a table and you have to provide all
Yeah,
the
phylogenetic analysis I want.
Okay. So this is one way. Then after that, you can go to
click on TA and then go to C okay
TA9
model. You see the distance. You have to compute pairwise distance, compute overall mean distance. So what is it? You will get that full table.
So now you know
After
the
doing all
conserved
this,
size are how many.
so that also you have the example. And another thing is your grade. The grade.
So like that you can see all the size, okay?
Gamma
So content
parameter
side, how many are there?
and,
The
position,
position side, how many are
position.
there? Variable, the conserved region, how many are there? Variable region, how many are there? It will work, darling. Click on that.
And what is the meaning of gamma parameter? Yeah, go to another window. Yeah, put the gamma parameter. Yeah, why we are giving so much importance to that gamma parameters?
You don't have conserved region. See, if this conserved region is there.
Gamma parameters,
then
phylogeny.
similar, okay? Same sequence, if present in
Gamma parameters,
every
phylogeny.
okay? You don't have anything, okay? You have variable region, okay? You have
See,
parsimony
what is
side.
gamma distribution in phylogeny?
Parsimony side.
Exactly that.
And someone singleton side. Parsimony side, parsimony
So
side.
what you are observed known this thing? What is the parameter of gamma? Gamma distribution of two parameters, alpha and beta.
Where the minimum number is coming.
One is shape, another is rate.
Okay? That is the parsimony side.
Okay, what have you understood? And then what are all the parameters for phylogeny? Click and see. Yes. See, this gamma parameter normally shows your substitution pattern. So that is why we are giving a lot of emphasis on that gamma parameter. How much amount of substitution happened? Whether it is a non-synonymous or synonymous. So that shows your gamma parameter. That's why you have to do and you have to give that tabular column. Okay, have you done that one? Yeah, you show me that after doing, you show me that thing. Because there are, two things are there. One is X, another is Y. So that point you have to do that. And your mutation rate is there. Rates. Or that's why rate is your that's a gamma parameter. That is I want to say.
This is this or this is
That is you can go to diversity. This
Selection.
clock. Yeah, you go to clock. Tajima, yes. See, all you have to go to clock here. Clock, Tajima test is there. Tajima test only.
Tajima new selections and selections.
Selections. No, my one is clock also there. No, what is molecular clock here?
Change in
So, over period of evolution, transition is equal to transversion. You think same thing here, that is molecular clock. So we are testing. Oh, is it same or not? Understand? So that is very, very important. See, that is called the Tajima test of neutrality. This Tajima's test of neutrality showing that your transition and transversion same or different. You will get a value. You do that thing, yeah. You do that, no, you go to selection. Go to selection and select the Tajima test of neutrality. Go to selection. Not here. Selection. Selection. Yes, Tajima test of neutrality. Yes. There you can do Tajima test of neutrality. You do it. See, you will get that thing. Very, very important part is the total number of sites, number of segregation sites, correct? What about your nucleotide diversity? And D is your Tajima test of neutrality. So what value you are getting? So that is very, very important part. That's why before preparing this table, you have to be very clear about what is Tajima test of neutrality. See, here we are testing what disparity is there. Everything is same or different? Variations happened or not? That shows your Tajima test of neutrality. So you have to prepare a table and you have to provide that. Correct. Then after that, you are going for that phylogenetic tree. Phylogenetic tree, what model you are giving? That is very, very important thing. That's why, whether have you seen or not, yes. Have you selected that one? Or default thing only you have given? Suppose you say if you are going for maximum parsimony, click maximum parsimony. Yes, we are going there. Maximum parsimony. Bootstrap is there. What is the meaning of bootstrap? Whenever you are generating trees, bootstrap is there. What is the meaning of that thing?
Like how many, if we give 500 times it will construct the same tree and give the variation.
See, bootstrap is nothing but iteration. Iteration. So why we are following iteration? That's why, see, these are all the things you should know. You see, for example, we are doing protein estimation. We will do only one time. Correct. 20.6. With that, what kind of statistical analysis I can do? Correct. I can't do it anything. Same way, I can't do protein estimation 10 times or 30 times. But I have to perform statistical analysis and I have to mention n is equal to 10 or n is equal to 5 and I have to show. So for that, what you are doing here? Suppose if you are getting protein estimation, you are getting 20.6. So what I will do? 20.6, 20.5, 20. This way I am generating that data. That is called iteration. So same way here, your lot of sequences are there. Whether it is amino acid or nucleotide. So same thing is, suppose if you are having only 5 only there. You are making that thing into 5,000 times. 1,000 times, 500 times. That's why that is called bootstrap thing. So that means here nothing but, see, already you know that in statistics, that madam also showed on slide. You increase your sample size, yes, you will get a very good data. Correct. If your sample size is not good, you will end up with a bad result. Same thing. Bootstrap is that thing only. So that is why you have to select that bootstrapping method. There you have to give whether it is 500 or 1,000.
You have to give the value there.
You have to give.
How
so
many
minimum,
times you want?
Minimum. You have to give 1,000. Okay. Yes, that's why I'm telling you. So this thing you should know about bootstrap method. So that thing you have to select. And any model is there. Here they are not telling any model not at all there. Okay, that means these are all now this version they are inbuilt. Previous version if you are seeing there, you have to select that model. Juice canter, model. Then automatically it will build a tree. Now okay, already you have done, so automatically it is there. So then you are putting into yes, okay, yes. So my point is, now you are doing maximum parsimony. What is the basic principle in maximum parsimony? Now you get the result. You do that. Okay, how to export your result? See, you are getting this tree. How I will get that thing?
Image option.
Okay, you have done that phylogenetic tree, correct? How to get this thing? So go to image. See, in which file do you want? PDF file or TIFF file? Yes. See now, if I want to change that font size or anything, yeah, you can do it here. You have to play all these things, what font size, horizontal, vertical. Even if you want to increase the size of that your tree, no? Yes, tree line, you can increase. So that is why your presentation of the data should be, yes, perfect way you have to do this. You understand?
Normally we are considering
So
about
that thing you have to do.
9% boost.
Yes.
That is good.
Okay, then you can copy as PDF file. Yeah, what it is coming, you see. Okay, save as PDF file. Yeah, what it is coming. Open that PDF file, then you see.
See now this cheese with bootstrap.
Save, yeah, put image. Go to image. Yeah, save as PDF file. Give your name. You save it and open it. What it shows. Any description is there? No description, huh? Oh, nowadays this version description is not coming, eh?
Sir, please here.
Image.
Image.
Save as PDF, whatever.
For you, see,
But
Hey, see below that display caption.
display caption.
See, then only it will come. Display caption.
Yeah.
That thing you have to click. Display caption.
Okay. Yeah.
Then, yeah, below that, yes, you will get. So now you read what is maximum parsimony. It is written here.
Analysis is also involved.
Correct. That reference also there. So what is maximum parsimony? What is maximum parsimony? See, what is your parsimonious tree length is 137. And consistency index is this much. Retention index is this.
What is the meaning of this?
What is maximum parsimony?
Okay, sir.
Go to window.
I'll read.
Yeah. Hey, you go to another window, you write maximum parsimony. What is that? Maximum parsimony, what principle we are following? Because in maximum parsimony, 3 index is there. Your retention index, maximum parsimony. It's a character based this thing. Yes. See, you are generating tree, yes, by minimizing the total number of evolutionary steps. What is the meaning of that thing? Minimizing the total number of
Sir, the
evolutionary steps.
Yeah, evolutionary steps.
What is the meaning of that thing? See, maximum parsimony is the character based, correct? So you are generating the tree. So see, as a permutation combination, you will get several things. So in the thing where you are getting minimum branch length, that thing it is selecting.
That's why we are telling you.
Please remember that thing. That is why you see that the caption. Yeah, branch length is branch length is
Why are we bootstrapping now? Bootstrapping is very important. Without
that thing it is coming. Hey, you show your maximum parsimony.
So that length is coming.
See here. Length is 147. Are you getting?
Yeah, what is the meaning of this?
You are not getting, huh? That is the minimum length. 147, yeah. Yes, minimum length is 200. So in your case, you are getting 200. So this thing you have to mention in your table. You understand? But here you are not getting anything. Why? No, have you done alignment? Okay. But here you are not getting. See, three parameter is there. One is branch length, minimum parsimonious tree length, then consistency index and the retention index. See, consistency means you are minimizing the length.
First of all, I am not getting length is what?
In that it is selecting, there is minimum step by which one you are getting. That thing it is shown. That is why 147 lunch, that which you are getting other thing more than 147. That is a and here you are maintaining the minimum length. Consistency very important part. Suppose you say your value is 1, 2, 3, 4, 5. So variation is very less. But if you are getting 1, 10, 50, that shows your consistency. See, my point is, that's why you have to read several published papers. Then only you will get a lot of knowledge. Understand? Otherwise, you are just clerical job only you are doing. You are not a scientist. All tools, yes, tool will do. But only thing is, how we are, interpreting that result. So for that, you have to read lot of papers. How they are. Okay. So this is maximum parsimony, minimum branch length. That is very important thing. Then you go to maximum likelihood with the caption. What it is coming. You see. Because normally you see maximum likelihood, if you go, it will take long time. Normally, it took long time.
बहुत अच्छा
One time they so that way you can compare your result with the caption, what it is. You see, another important point is you are developing different trees. Distance based, optimality criterion, character based. But problem is, what is your concept? So which tree, giving matching with your hypothesis. That thing only you have to select. Others they are telling, oh, character based is better, maximum likelihood very good. Don't do it like that. That's why, what is your hypothesis and what is your sample and what kind of sequences you are getting, accordingly you have to do that. Okay. No, that is why I am telling you, you have to do lot of practice. Then only you will know about this.
It's there. Go there. It's there. Very nice. इसको समझाना
So whatever caption it is there, clearly you have to take that data and you have to represent in that table. That is very important part. And another important part is say you are doing work, but if you want to publish in impact factor journals, you have to be thorough in that concept. Otherwise, very difficult to publish this kind of papers because all are doing barcoding. You will get a lot of sequences. Same thing you are doing metagenomic thing. Yeah, you will get. But publishing in impact factor journal, yes, you have to have a strong hypothesis.
Now build one UPGMA tree. Now build one UPGMA tree. And one maximum likelihood also.
And that's why you see that caption.
What is the difference?
No. Have you seen what kind of differences you are getting?
Yeah, what are the difference? Why we are building UPGMA? Why not parsimony? Just see the differences in the tree.
That's why you have to export and you have to copy that thing in your Word file. Then you have to check all the 5 trees. So there, what kind of relationship are you getting? So you have to analyze. Then yes, you have to come to a conclusion. That is why, because these are all knowledge based. So you have to have thorough knowledge on your concept. Then only you can interpret your results. That is why most of the students, they are not in a position to write one line. And they are telling, they are showing very reluctant. I don't want this. That is the biggest problem. First they will show all interest. Oh, I'll do metagenomics, transcriptomics, genomics, that thing. But after some time they will say, I have to use my brain. I am sorry. That is why. That's why before choosing any field, you have to be thorough in that thing. Otherwise, yes, especially this kind of molecular part, molecular evolution, the same. Yes, very difficult to publish papers in impact factor journals. Because whenever you are coming to molecular phylogeny, you have to be very thorough. One is, if you are doing on taxonomy, yes, you should be very thorough in taxonomy. And if you are coming to that functional part, yes, you have to be very thorough in that functional part. So what do you want to address?
For that, what model you created, you have to select it. But in case of UPGMA, you will not get any, like this one, select model. That's why, there is a difference. Here you have to select model, based model.
So, you see, one of the participants is telling, you want to clear net, you see, in net exam they are asking. They are giving the phylogeny maximum likelihood. Okay, what it is there? See, JTT matrix model. Yeah, because already you have done that where which is the best model. Right? So, maximum likelihood totally based upon model based. That is why all are telling you use maximum likelihood. But normally you see, whenever you are publishing paper, they will not accept mega thing. You have to go for Bayesian method. Yeah, so many things are there. Okay, but for this thing, see, what is your log likelihood ratio? Minus 1461.81. So that is the log, that's why log odd ratio you are getting. So that much significant it is. Correct? So this is, that's why I am telling you, you have to see all the 5 trees in one thing. Then only you can see, no? Same pattern coming or different pattern is coming. Because normally as a teacher, we are facing problem with the student is they are not using that hypothesis. All are doing, all are hard working, but no use. You are not in a position to set a concept, sir. This is my concept, sir.
And here R is in
That is very important part. Otherwise, whatever you are doing, so only. That is why you have to be very careful in that concept part. Before doing, you should know many things in your field. Because already you have seen that metadynamics. Yes, same that sequence you can do it here. So that way you can see what kind of suppose, see for example I am telling you that normally you take metagenome, this lactic acid bacteria playing a major role. So yes, in that particular group, yes, lactic acid bacteria forming a major thing. Even that lactic acid bacillus bacteria, all are same or different. So that thing you can show through this kind of phylogenetic tree. But this thing you are preparing in kind 2 or in R. But same principle. That's all. Please understand that point. So one is tree. So that way you are showing that time, how much time by which it differed in course of time. That is one thing. Then if you are coming to principal component analysis, that is only visualization. So where cluster form. If it is different, it will form different cluster. If it is same, then it will form in one. That's why we are telling ordination problem.
Then connector 2 एक हाथ में इसलिए ये one है ना.
Yes. So this is the point you should know about this molecular phylogeny.
यहाँ भी you cannot keep here, okay? So you have to keep here one and here one, okay? That is the thing, okay? Which is the base model? Now this is the base model.
Oh, she's maintaining that mice. We have covered basic.
Yeah, they are this is net and the J.
See now this is what? What's the tree here? What's the tree here? This one is which tree?
And also that help section, whatever the terms and other things, they have given explanations. That's why you have to study several times. Initially it is very difficult. You may not in a position to understand many things, but you have to study and you have to involve. So then, yes, then you know many things. I hope now you know about how to use Mega. Huh? Good. Okay, then that's all. Any other thing is there? Hey, you type in Google window, you can go to type homology. Homology, orthologous, paralogous. Homology. Homology, orthologous, paralogous. Right. Go to image, yeah. Yeah, you can click this one.
Which one, sir?
This one. This one. See, now you tell me, see the picture and tell the story. What is homology? And what is orthologous? What is paralogous? Click that one.
Similarity, you do common.
See, this is a simple picture by which anyone can understand. Not this one here. This one.
Then it came to that. And then from that, it came to that other methods were.
Yeah. Now you see the picture. What is orthologous? What is paralogous? Two terms are there: homology and homoplasty. Homology, sharing the common ancestor. Correct. That's why you see the tree. Everything originated from one. Correct. That is homology. Same origin. That's why now you see the tree.
This early globin gene.
That's why see early globin gene is there. Yeah, see how it is diversified. Okay, now you tell me what is the meaning of orthologous and paralogous after seeing this picture. Yeah, what is your explanation? Yes, are you getting anything? Any point? You use your analytical mind. Yeah. See the picture and tell the story. Like first standard kid. No? You are showing one cow. That fellow will say, oh, tail is there, eye is there. Correct. Horn is there. They will say, like that. You see and what? Yes. Thing you are observing.
Sir, pathology is the same common ancestor. In pathology is
Here one is globin. You see your gene of interest is globin gene. Correct. Now, yeah, you can develop what it is. Globin gene. Yeah. See, that's why early globin gene is there. That is your origin, correct? Then after that, because of gene duplication, correct? Yes. That globin gene is divided into two, alpha chain and beta chain. Yes. Now you know alpha chain and beta chain. See, what is the role of globin gene? Window, yeah, right? Function of globin gene. What is the function of globin gene? Carrying the oxygen. Is correct? Answer is correct. Carrying the oxygen. Correct? Correct. Carrying the oxygen. Globin gene, yes. So that is a heme protein. So it is carrying the oxygen. Yes, that is very important part. Now you tell me alpha chain and beta chain. What is the role? You type it. Globin alpha chain. What is the role? Globin beta chain. What is the role? Find out what is the function of alpha chain and beta chain. Anyone have you seen? Because globin gene is a macromolecule, right? So that is containing 4 subunits. It is normally present inside your red blood cells. Correct? So alpha chain and beta chain we are telling. So 2 subunits, yes, we are telling alpha chain. The another 2 subunits we are telling beta chain. That is based upon your molecular weight. Right? What is the beta chain? What is the? I think yeah, 147. Yeah, hemoglobin A. So that is containing 147 amino acids and molecular weight is 15 kilodalton. 15 S. 15 kilodalton. And what about beta thing? Beta polypeptide chain.
146.
See, you have heard about thalassemia.
Yeah.
What is that thalassemia? Because your beta chain affected means you are suffering from beta thalassemia. Correct? If it is affected alpha, so alpha thalassemia is there. So 4 subunits are there, 2 subunit forming one and another subbing this thing. Correct? So either alpha globulin or beta globulin, everything formed in the liver. That also carrying lipid. Please remember that one. Not only oxygen, that also carrying lipids. So that is very, very important part. And the globulin genes are playing a major role in immunity. That's why we are telling immunoglobulins. Right? See, different types of immunoglobulins are there. So that's why be careful about that. We know about what is globulin gene. So many functions are there. So now you go to your orthologous and paralogous. Yes. What? Yes. What is the story you are telling? What is orthologous? What is paralogous? Anyone? Can enlighten us? Whenever you see, we are talking about biodiversity. What is the meaning of biodiversity in terms of molecules? Biodiversity. You see here, whenever you are telling orthologous, please, orthologous genes, whenever you see, we are talking about biodiversity. So whenever you are seeing any gene sequence, you have to find out orthologous genes. Then only diversity is there. That is why you see orthologous gene. For example, alpha chain. So that is present in frog, chick and mouse. Same way beta chain also